Hi, welcome to this session on Snowpark Container Services. I'm Luc Del Salle, VP of Engineering at Tenable, and today with my coworker Rocky, we'll tell you more about how we are using Snowpark Container Services to power Project Compass, an AI assistant, designed to achieve cutting-edge cybersecurity needs. We'll start with a quick introductions on why Snowpark containers in cybersecurity, and then we're going to jump into technical deep dives on our project. A few words about Tenable. We are a cybersecurity company. We offer a lot of different products that help customers understanding cyber risk. There is tons of cyber risks today. This is why we have so many products. And the challenge from a cybersecurity point of view is to find a way to make all these products, communicate with each other, to make sure that they share information all together in order to achieve that, to make sure that, security practitioners can have a holistic view of this risk. And this is why we created the platforms. It has been more than 20 years now that people are doing cybersecurity, and attackers are still capable of breaching in, stealing data, stealing sensitive information from our customers. And we believe that this is still happening because today organizations have cybersecurity measures in place, but they are not having cybersecurity measures that can cooperate with each other, like being able to have all the cybersecurity products working together to detect risk and provide, as I was saying before, a holistic view of the risk for decision makers and security practitioners. At Tenable, we created that platforms that can integrate, risk and information about assets like devices, kube clusters, web applications, everything in one place, so that customers can see all their risk in one central place. They can understand how they can remediate from their risk, and more interestingly, they can understand how attackers will exploit this risk. We name it attack path analysis. It's really about putting risk together and chaining them together to understand what is the most likely attack path that an attackers will follow. And we do that not only with our data. We understand that there's lots of cybersecurity vendors, and we do that for all the vendors that are willing to integrate with our platforms. From an engineering perspective, how things work is quite simple. We bring all our data into a data warehouse. This is why we are using Snowflake. On top of it, we create what we name an exposure graph. It's, in a nutshell, a security engine that look at our data, connect the data with each other to detect cybersecurity risk or attack pathways, as I was explaining before. On top of that logical layers, we have AI capabilities. I will drill into it in a second. And finally, on top of these AI layers, then we have the data, we understand the risk, we have AI that make the data smart, then we just need to present it to our customers through different consoles. This is how pretty much work Tenable One, the Tenable platforms to manage cybersecurity risk. Now let's discuss a little bit AI. Clearly, AI is a buzzword today. Lots of vendors are using it. And the legit question you could have is, okay, is it actually useful for cybersecurity? And the answer is yes. AI in cybersecurity, was definitely a game changer and helped organization, fight against more advanced cyber risk for multiple reasons. As you can imagine, cybersecurity, we are collecting a lot of data coming from a lot of different products, antiviruses, firewall, containers and vulnerability scanners, and a lot of other products. Having an AI that allows us to understand what are the relevant data versus the rest is absolutely key. So data processing, AI is helping a lot. Attack discovery. The key when you do cybersecurity is to detect security incidents as soon as you can. If you detect an attacker that already have access to your data and already stole the data, well, it's great, but it's a bit too late. Let's try to be a bit more proactive and let's try to be able to detect attackers when it's at the first step of his attacks. Usually it takes several steps before reaching his target. Let's try to detect it when he's just doing recognition on your information system, for instance. That's attack discovery, and being able to detect the weak signals, allowing to detect attackers sooner. AI is pretty good at it, and this is why cybersecurity is using it. Same thing for prediction. You have tons of risk. The challenge is to be able to know, to discover which one will be the one that will be actually exploited by attackers. AI is typically an AI work, and AI is helping a lot into predictions. And finally, accuracy. That's something super important for our customers as well. Because we are aggregating so much data, and because we are trying to find all the risks that could potentially exist, from time to time, cybersecurity product can generate false positives. The idea is to use AI, train an AI models to understand what are the common patterns of false positive in order to reduce them as much as we can. Again, it's type of job that AI is super efficient. And this is why we are using AI pretty much everywhere at Tenable. Let me give you like 3 customer-facing features that use AI today. I'm going to start with the first 2: the vulnerability exploit intelligence and the attack path explainability. The idea of these 2 customer-facing features is to actually help customers understanding the nature of the risk that they are facing. Because we have so many different types of risks today, because it could be a software bug, a misconfigurations, a patch that hasn't been applied, or a password that's been breached. Customers can be uncertain on the type of techniques he needs to put in place to prevent the risk. So we use AI not only to predict, not only to reduce false positive, but also to help our customers, understanding a given risk and knowing what to do to prevent their organization from being impacted from this risk. Same thing for attack path explainability. Attack path is, as I was saying before, the step that an attackers will follow to, gain access to a system. The idea is to explain with human language words what are these steps, so that again, in the mind of the decision makers, you can better understand what it is and and improve the strategy to prevent such incident from happening. And then the last one, and we're gonna drill into this in a second, is our AI assistant. That's and we named this project Project Compass. You're gonna hear this name in the second part of this presentation. This AI assistant is really like, a chatbot that helps decision makers, security practitioners to know what they have to do when they need to deal with cyber risk. Today, you could have like thousands of vulnerability risk, and really more than 100,000 risk in large organizations. It's quite challenging to know where to start, what to do first. Having this AI assistants really help our customers, the organization in general, to know what are the most critical risks they have and what they need to do to address this risk efficiently. And this is this AI assistant that is using Snowpark Container Services. The question, why we are using SPCS in our product is quite simple, because it's an LLM based features. Because it needs to be fine-tuned each time there is a new type of risk or a new vulnerability that appears. We needed the solutions that was allowing us to quickly fine-tune our models, update the different components of these models to provide relevant answers to our customers. So we need something that we need the solutions that were that we could give to data scientists that are not developers, so that they can do the updates, do the change on the model without requiring any engineering support. And Snowpark Container Services allow that. The second thing is, because cybersecurity data are so important, we needed to be sure that the data that are used to train the model are not shared to any third-party services. We need to be sure that the data remain in on our data warehouse and never leave this data warehouse. And for all these reasons, we believe that Snowpark Container Services was the right solutions for our needs to empower Project Compass. Now I will hand it over to Rocky for the technical parts, so that you understand a bit more how everything's work.
Hello, everyone. Welcome to this Snowflake build demo. So what we want to do in this demo was demonstrate some of what Tenable has been working on as far as AI technology and how it can work well together with its products. So we're going to demonstrate today is a prototype we've been working on called Tenable Compass, and we want to show you ways that we think this could possibly integrate into the new Snowpark Container Services. I want to start off with this architecture slide so you can have a better understanding of what's happening in the background and can better understand what's happening once we get into the demonstration and the code. There's a lot of back and forth communications that happens both between Compass and the AI. And so I wanted to show you kind of how that flows. So starting off in the top left-hand corner, you'll see where there's the Compass front end, the JavaScript that's delivered to the browser. From there, it goes to a public endpoint that's offered by Snowpark Container Services called an integration, which handles our authentication getting into the application. Finally, once we're inside of the Snowpark Container Services, you see that we have two services running. We have the Compass service, which handles the main part of our code and communication. And we also have the Falcon LLM service to the side. That's the AI, the open source AI we chose to use for this. But there's many different open source AIs that you could use. This one just seemed to work best for us in this particular prototype. So the communication is going to first start at the front end where someone's going to type a question into our chatbot. So Compass is going to receive the question. In this case, just keep it real simple for the sake of demonstration. It said, how many assets do I have? So each account is linked to a container ID and it holds all the asset information for that particular account. So whatever account you're logged into, it's going to capture that container ID and ask questions based on it. So a simple question is just, how many assets do I have under my account? So what's going to happen is this question is going to get sent over to the Falcon LLM service, and it's going to ask it to write the appropriate SQL to answer this question. So the SQL that would need to be sent to the database to retrieve data to answer that question. Now, before I go any further, I want to make something clear that maybe is not when I first started. When I talk about the user's account and container IDs, those can be used interchangeably. When you have an account under Tenable products, you're assigned a container, and that container holds all of your assets. So when I say like an account or ID versus a container ID, we're really kind of talking about the same thing. It's the container in which all the assets are inside of. So when you log in, you're logging into your account. But if you ran an SQL statement, such as what we're doing here, you're going to actually ask for the container ID. And that's the same thing as saying, what is inside of my account? So to do that, we're going to pass along this context to the AI. And this context is going to say you're a professional SQL programmer. You're going to send back SQL data and only SQL data to answer the question that the user provided. I tell it what the table name is they're looking at. I give it a few columns. This has been very narrowed down for the sake of just screen resolution in this demo. But some of the columns that are inside of that table, and then we send it an example. So I give an example, what if the person asks for which asset has a particular IP address for the container or the account in which they're in? I would expect the AI to then answer with select star from the database, where this IP and where this container, and wrap that in SQL tags. So I send that context, and then I send along this question. It comes back with what it believes is the correct SQL to answer that question. That then gets sent back to our Compass service. It then creates a session using the Python SDK for Snowflake, and then injects that SQL statement into the session call. That's then sent over to the database. The database runs the SQL query and then sends back to the Compass service what the answer was. Now, right here, it's a very simple answer. How many assets, right? But the way that looks, it doesn't really feel like you're having a human-like conversation with an AI. So we do is we go back to the AI a second time, and now we're asking it to explain it in more of a human way. So this time when we send back to it is the original question that was asked, along with the data that was returned from the SQL server. We then send a different context. And this context is saying, hey, communicate with the SQL server, data has come back. Now take the question and the data and respond in a very simple and natural language. So another example going off the first one is they asked what asset has this IP. The data came back, asset name SQL2. So we expected to respond with something nice like SQL2 has the IP address for this container. So we send that along. It then processes a natural language way. And then finally, Compass gets the response. You have 11,986 assets inside of your account. So that looks like a nice proper answer to what the original question was that was asked. So that's what gets sent back to the chatbot, and that will be your response that you will see from the question that you asked. I'd now like to take you through a demonstration of the application actually working, see what it looks like from the front end point of view, and go through a little bit of the structure that's set up both in Snowpark Container Services and then some of the code. As we're going through this section of the demonstration, I wanted to make something clear. So we actually started off using the open source LLM called Dolly that some of you may have worked with. And while Dolly's really good for the native language, it didn't work very well when we were trying to actually get it to respond to us with code. It just wasn't properly trained in that way. We found that Falcon did a lot more naturally, and we were able to train it a lot more efficiently to come back and answer us with SQL code. I say that so you understand throughout this demonstration, you're going to see Dolly a lot of places, such as this Dolly name right here, and Dolly probably throughout other places. And we simply just didn't go back and recreate all that. It wasn't necessary. So if you see Dolly anywhere, you can just ignore that. That's from us using Dolly as an LLM. And then right towards the end there, we switched over to Falcon and trained Falcon instead. So first of all, I'll show you the pool that we have going on. We're using the GPU3 family. You can see down here, we've set up the pool. It is active and running. We also have integrations we set up. I mentioned that in the first part where there's the public access point. And for this one, we are using OAuth in order to have our security for accessing the application. We also have those two services we talked about. Here's the first service, which is the Compass, and the second one, which is the Falcon AI that we discussed before. I can show you the services here. They're both up and running. And I want to show you also the endpoints. So for the Compass, we actually have a public endpoint. That's because this one actually needs to be accessed by the chatbot to hit the API and be able to get the responses. However, we do not have a public endpoint on Falcon, and that's because there's no real need to have a public endpoint for Falcon, and the less endpoints we have, the better the security, and we're really focused on security with this build. So we use service-to-service communication inside of Snowpark Container Services, which is really nice. It sets up this automatic DNS structure that we're able to use to communicate between the two services while only allowing one to have to be public. Okay, well, let's go ahead and open up this public endpoint we have so we can get into the application and see what it looks like running from the front end. Now, because of the integration that we created, we did set up with OAuth, and that allows us to be able to log in using our SSO, this particular case through Okta. And because I did this just recently, it kind of skipped through a lot of the steps of the OAuth, but showed that we've got protection getting into this. Okay, and let's ask Compass a question. We'll start off with the simple one that we used in the demo. How many assets does my account have? Okay, now you remember this is going through all the stages where it's first going to go over and say when SQL should be written for this. That SQL will then be sent over to the database, go back and forth. As you can see, it's very nice and quick with this all running locally and being set right next to the data. So now let's try to ask it something a little more specific. Now I know that there is a domain controller underneath this demo account, so maybe I'll ask it something specific to that. I will say, how many weaknesses, which is what we call them, you could also say vulnerabilities, does DC1 have? Now we're being a little more specific to an exact asset. We want to kind of zone in and say, what's going on with this asset and have it bring back more specific data about that. So again, it did the same back and forth, except this time it came back with the phrase that DC1 has 795 distinct weaknesses. Okay, now let's look at the back end and see what's going on by looking through some of the service logs that we're able to get through Snowpark. So I did this call system service logs on the Compass service, and then next we'll go through the Falcon. So what you can see in the logs here is that it first sees that it has received this question from the front end. This is what came across. Was requested through the API endpoint of Ask Compass. And so what it wants to do is it's immediately going to take this question and it's going to hit the API endpoint on the Falcon service called Ask Falcon. Falcon's going to process it through the LLM, and it's going to come back and say, here's your JSON response right here, which has a message, and that message is the SQL code that it says this is what you should run in order to get the information you want. Compass is then going to turn around It's going to send that over to the Snowflake service using that Python SDK we talked about. Snowflake's going to respond with the data. So now we see this simple structure of the assets. Now we want to get this, as we talked earlier, to convert it into like a natural language form. So we're going to now send this data over to the explain. We're going to send it the question and the data and say, hey, put this together, make it a nice message. And we're going to hit the explain REST API endpoint of the Falcon service. It's then going to respond with this JSON right here, another message, and this message will have the information or the natural language which we want to actually send back to the front end. So that gets sent to the back end. You see the same thing here. It's just repeating itself. How many weaknesses does DC1 have? Same thing, a little more complicated SQL coming here because it wants to be specific to an exact asset name. But either way, it comes back with weaknesses and the number. Again, we send that to explain. Explain comes back and says, here's what you want to send back to the front end. Now let's move over to the Falcon service and look at some of their logs. So again, the Compass service sent over this question to Falcon in the SQL endpoint, and this is what's received. It says, okay, I got the question. And now what it's going to do is it's going to send this to the actual AI and say, I need you to create this SQL. So we're going to see everything that's being sent over to the AI. So you have this introduction here, which we saw earlier. We need you to return SQL code. Here's table information. Here's the columns. Here's some examples. And then the very last piece of this context is actually this. So it kind of ends right there. And the very last statement is the actual question. So Falcon sends us over through the pipeline. It's processed locally inside of the service. And then Falcon responds back with this statement right here. And so we've already stripped out the SQL tags. We do that in the system to make sure we're just grabbing SQL in case it chats about anything else. And then finally, what we're going to do is, well, I guess this is the whole SQL statement here. We're going to wrap that up and we're going to send it over to Compass, which you saw, and it gets the JSON response and it sees this is SQL you should run. So the next thing that Falcon sees is once everything's been processed with Snowflake, it then receives that question along with the data. So right here is what it received. It received the user's question and also what the return data was. Then we do the same thing with the different contexts. As we said before, you're now going to respond in simple language. Here's an example of what that should be. And then finally, we end it right here. This is the actual end of the context where we give it the question and we give it the data. It says, okay, so then again, it gets processed through the local LLM and comes back and says, there's this message in your account. That is then packaged up. We saw that in the JSON response back to Compass, and then Compass responds to the front end. So it's a lot the same thing. Again, we get this one with the DC1 that we sent over, sends the whole introduction. It gets the SQL, sends that over to Compass. Compass sends back the question and data. It processes that and says, you know, here's your nice, pretty response. Please send that back to the front end. I'd like to spend just a minute here going over a little bit of the code really quickly. We're almost out of time, but I wanted to show you things like the spec file. Right here's the spec file for the Falcon. As you can see, we have the container name of Falcon, where we're uploading it into our repo. And then we do have an endpoint here. It's sitting at 8,000. But if you notice, we don't have public set here. And this is what gives us our endpoint and allows us to do the communication, but service-to-service communications. Again, helping with that security to keep some of the communications internal. For the Compass, a lot the same thing. We have the image and stuff like that. But what we're putting in here is environment variables. And this is what allows us to use that internal DNS system for that service-to-service communication, me being allowed to inject that in there and knowing that whatever the DNS name it comes up with, using the short DNS name, that it will always be the container name. I'll always know that I'm hitting the Falcon service each time this comes up, and that's really helpful. Our warehouse, and then you see with this endpoint, this one is actually set to true, and that's what gives me the endpoint that I need to access it. Now, walking through the APIs a little bit, we'll go ahead and start here with Compass. This is the Compass API. It's a very basic and prototype Flask kind of setup for this demonstration. Has one major endpoint here, which is the Ask Compass. It creates a Snowflake session instance, and then we're getting the user question here. We're logging that. We're then sending it over to that Falcon API that we just showed you. The Falcon responds back with what SQL it finds, It then takes that SQL. Here's where we send it over to Snowflake using that Python SDK and actually getting the data response back. Finally, we go down here, send it to the other endpoint, which is the explain that we talked about, to give it more of a natural language feel to it. And then that's what finally comes back and gets returned to the front end service. So for Falcon has its API here. It has those two endpoints we talked about, the Falcon SQL saying, we need to get SQL, and then the Falcon explain endpoints. The first one is going to send it over to the Falcon SQL, which adds in the correct context, gets the SQL statement, and then this is the one that actually sends it to Falcon explain and has it give that natural language. And right here, you can see what we're using. It's the 7B instruct version of Falcon, and we have it set up with that SQL context we were talking about, and then we take the context, plus adding in the question. We have all that sent over to a pipeline, and that's what gives us our responses. So really quickly, as we wrap this up, I wanted to go over why it is that we are looking at Snowpark Container Services for some of the tenable prototypes that we're writing. Obviously, all of you understand the sensitivity when it comes to data and why this AI technology is great. A lot of times it means shipping your data out and having these AIs out in the cloud process it, and now they have a hold of your data, and whatever they do with it, maybe we're not aware of. And so we wanted a way to make sure everything was contained as possible. So the really nice thing about running the Compass prototype inside of the Snowpark Container Services is that we're keeping everything local. So our code, the Compass, is actually running right inside the container services. Right alongside with it is an open source AI that's running offline, and all the processing and everything is happening directly within those container services. And then our data, which lives inside of the Snowflake databases, is also right there. So we're keeping all of the processing, the gathering of the data, any manipulation of the data, anything happening directly inside of those containers. And that's very, very important to us to make sure that our data doesn't get out there, customer data getting moved around. We want to keep things very local, but still leverage this beautiful AI technology and have it run right next to our data. It makes it secure. It makes it very fast, very efficient. And that's why we've been looking into this. So I hope you enjoyed the demonstration today about different ways that Tenable is trying to leverage AI with their products and seeing how it fits with Snowpark Container Services. So thank you very much.